to say, if someone were going to describe Earl, he was physically fit. And, this is a classic example, a hiker, a runner, a weightlifter, and I would say also, based on his later years marathon running from the valley, which I might have been able to use to cycle in the valley to his work somewhere down south. He had great endurance, not only physically, but also scientifically. And the other thing I like about this picture is his contemplative pose. I mean, this just brings back memories of Earl. He would be in his lab in the BRI at his drafting table, editing manuscripts, and he would have on he might have a visor on, he might have his jeweler's boots, but in any case, he was editing manuscripts. And anybody that had worked with Earl on manuscripts knows that they were in for a major problem of revision. Constant revisions. And I was with Earl in the mid-70s, and that was when we had cut and paste. You had to, Earl would mark it all up, and you'd have to sit there and, first of all, just put away your self-esteem. And you would have to take that manuscript that he had edited, and then you would have to type it up. And then you'd think, okay, that's good. And the next thing you knew, it was another revision. So I forever remember that. And that, to me, that's the classic picture of Earl. Just sitting there thinking about his next move. All right, so, Earl's scientific career started at Northwestern in medical school, and during that period of time, he published his first paper with Ray Snyder. And Ray Snyder was in the anatomy department at at Northwestern. And importantly, also in that department was Horace Tig Magoon. And Magoon, of course, is famous for having done some basic studies during the late 40s and the early 50s on the reticular formation and its role in arousal. And so at that point, somewhere around the turn, I guess about 1950, he became the first chair at UCLA in the anatomy department. And during that period of time, as indicated here, he also offered Earl a job. And so that's what happened. Earl came to UCLA and began his long career at UCLA. Now here's a picture of Charles Sawyer and Earl, and along with Magoon, who was instrumental in starting the BRI. Charles Sawyer was as well, John French. The three of them, well, actually there was a fourth one, which I'm blanking on right now, but so there are four individuals that start the BRI, but certainly Charles Sawyer and Magoon were very important in starting that institution. This is a picture taken from, I can't remember what it was taken, but it's of Sawyer and Earl at the location of the first medical school, which is, I think it was around 51 to 54, somewhere right there. Honestly, I don't know where this stone is located. Somewhere around here. It's just, where is it? The thing is that, Earl, during his career, at least in terms of departmental responsibilities, he was acting chair for a couple of years in the late 50s. I know he was a vice chair of the department, and I know at some point he was also in charge of the willed body program. And the willed body program is something that you would like to avoid. It's one way to get fired if things don't work well. As I went through Earl's CV, I noticed that there was a reference with Eldred on the paper, and the study and demand, supply and demand for faculty in anatomy. So Earl really had an interest in medical education, training students, both medical and graduate students, and I think this is an offshoot of that. The other thing that I saw when I went through his CV was I had no idea, or I had long since forgotten, that he actually worked on blood. That was, to me, was something new. And so Earl and Berg had published 3 papers together, which are listed here. And if you look at this picture, you see Berg sitting next to Earl, And the gentleman to Earl's right is my father-in-law. And I'm quite sure that he was asking Earl, why did it take me so long to finish my dissertation? And I'm pretty sure he was asking him, was he going to get a job? Now, I don't think you can see it, but on my t-shirt was the word anatomy spelled with bones. And it was prophetic because I've been at UT Southwestern for the last almost 40 years teaching gross anatomy. So that was a legacy that I got from Earl, having been in the anatomy department, and I've had a job for a long time. Now, Ragnar Granit, who received the Nobel Prize in 1967, basically for his work on vision. He basically recorded from single cells in the retina and established the 3 afferent pathways for color vision, red, green, blue. Around the time, I'd say about 1950, he changed his orientation, his scientific orientation, and started studying motor control. And one of the most influential papers of his time that he made the switch is what's shown here, supraspinal control of muscle spindles and its significance. And if you notice, the first author in this paper is Earl. So this is the time when these investigators were starting to look at the influence of descending systems, predominantly on the gamma motor neuron, but also on alpha motor neurons, which apply skeletal muscle. And it was a landmark study and paper, and I really think it set Earl on his way. It certainly consolidated his importance in his mind about motor control and the roles that muscle spindles played in motor control. Now, I don't know if you can see it, but there is an asterisk by his name, and that indicated he was a Markle medical scholar, which is no longer a scholarship, but in those days it offered $5,000 for 5 years. Doesn't sound like a lot of money nowadays, but I'm sure it was then. And I'm not positive, somebody in the audience may know, that probably helped him go to Sweden and work with Granit in his laboratory. It was a prestigious award, as I mentioned. There was about, I think there were like 50 per year, and you can only have one person nominated from the medical school, and so Earl was one of those award winners. Now, Earl has a really distinguished pedigree. Obviously, Granit, he had published 3 or 4 papers with him in the early 50s. And when I showed up for a postdoc in Tucson with Doug Stewart, he pointed out, quote, my pedigree. And obviously through Earl, through Granit, it's a bit self-serving, I agree. Also traced back to Charles Sherrington, who also received the Nobel Prize in 1932. And Sherrington worked on reflexes. And he was one that came up with the concept that a reflex, it is the sort of fundamental basic thing that is integrated by the central nervous system. They're a very fundamental element to motor control. And he was also the one that coined the phrase synapse. He was a proponent of the neuron doctrine, communication between neurons, that there was a synapse. And importantly, he also coined the phrase proprioceptive end organs, which would include muscle spindles. So Earl's trajectory through his scientific career really can be traced through these 3 individuals, or these 2 individuals, excuse me. So here we see the muscle spindle that Earl spent so many years studying. So it's a proprioceptive end organ. It's a length sensor. It gives a reading of the instantaneous length of a muscle. It has 2 flavors of sensory elements going back to the central nervous system. And as I briefly alluded to, it can be controlled by the central nervous system through its gamma of innervation. So you can set the gain of this receptor to changes in length based on the status of the animal. And as I've indicated here, Earl had, of his 100 papers, I've just counted them up, there's like 75% of them that were directly or indirectly related to the anatomy and physiology of muscle spindles. And I also might add that
there were a number of really influential reviews that Earl put together over the years on posture, muscle spindles, and basically motor control. And he also, I believe it was in the mid-70s, had a real extensive bibliography that he published about muscle receptors. This was before PubMed, where you had an electronic database and you do the search. I mean, he went out and actually published a paper that had, I think it was 156 pages to it, so you can continue looking at the literature going back from the present when he started the review all the way back to the initial papers that started talking about muscle spindles and other sensory elements. Now, in the memoir of Ragnar Granit, Sten Groner, another Swedish neurophysiologist, stated that the essence of good science is to formulate testable working hypotheses of relevance to the current stage of development of a given area, and to be able to design and carry out the appropriate experiments to be able to reject or support hypotheses. And I think this description fits Earl to the T. And I have a brief example of it, and I know there are a lot of words there, but basically in 1993, when Earl was formally retired, he was an emeritus professor, he published 2 papers with Steve Perlmutter, and these 2 papers were concerned with high-frequency stimulation of spindle afferents. And you may wonder why that was important. Well, in rehabilitation medicine, electrical stimulation of nerves or even muscle directly is often used to rehabilitate patients, central nervous system injuries. You can hopefully facilitate improvements in gait, prevent atrophy of muscle following disuse, and sometimes it's used to alleviate the symptoms of spasticity. And generally, the thought would be that you can make exercise possible. Now, one of the issues about that, and I think this is one of the reasons why I really think Earl was terrific at these kinds of experiments, and the reasons for them, is that he recognized, and others had recognized it too, is that when you stimulate a nerve extracellularly, in other words, you're not using any means to activate a muscle from a central source, you actually recruit the largest axons in the nerve first. And what that means functionally is that those axons are connected to the most fatigable motor units, those that are causing muscle contraction. So that's exactly the opposite of what you would want in this situation. So what you're doing is you're stimulating these nerves and you're reversing the normal recruitment order. Now, there's one way of getting around it, and it's been proposed that what you do is you stimulate a nerve at very high frequency. And when you do that, you actually block the fibers that are with the appropriate stimulus strength that are supplying the muscle. And then at another site, you can stimulate the nerve, and then you can bring in the more fatigue-resistant motor units. So it's a way of mimicking normal recruitment. Now, Earl, in this experiment, these two papers, really didn't have a, quote, hypothesis. He basically said, we have no idea what this high-frequency stimulation does on the afferent side, the sensory side. So that was the rationale for the study, to investigate why and what would happen if you stimulated in a clinical setting at high frequency. How would that affect the sensory inflow into the nervous system? Now, I'll just summarize by saying that, and this little picture kind of shows you, I'm going to have to move away from the microphone. So this is the sensory fibers right here. So what Earl did, and Steve Perlmutter, they would tease out individual axons, the sensory axons, something that we did many, many times over the years. And then at another place, and these 2 points right here and here actually could be a muscle nerve. And you would stimulate this muscle nerve, and you would basically, with high frequency stimulation, then you would study the effects that it would have on the single afferent that has coming from that muscle. So the take-home message was, as I've listed right here, is that there is a post-stimulus depression. And the other main conclusion is that if you look at this depression, you're obviously also at the same time diminishing the effectiveness of the sensory inflow, in the sense that you're putting a tremendous sensory barrage into the central nervous system, and you are also affecting the peripheral element. In other words, the muscle spindle is no longer sensitive to stretch over a period of time. So this is something that many of the rehabilitation people really haven't taken into account. And I think this is a terrific example of Earl's looking at what can be done with the sensory inflow and how it may influence the behavior of patients that are undergoing this kind of stimulation. Well, what I've done here is listed some of the association Earl had while he was at UCLA. This is by far not complete. Don Lindsay, by the way, was the fourth individual that helped fund the VR, which I forgot. Doug Stewart was a postdoctoral student of Earl's and was my postdoctoral mentor. Reggie, obviously, has been around and published with Earl over the years. Judy Smith, Bob Hutton, and others along the way. And of course, I listed also your Steve Perlmutter. I went to the archives of the UCLA library to go through the thesis. And as far as I can tell, these are the doctoral students of Earl over the years. And I had the great privilege of being, I think, his last postdoctoral student. And I've also listed some of the more important visiting investigators here. And you'll notice that there's a strong contingent for Japan. I think they really like the Southern California weather and the scientific environment they found themselves in. So, this is, I think, a fitting end to this talk. This was taken at the top of Bishop Pass, slightly under 12,000 feet, and shows Dan and Earl. You know, I had a great time. I mean, I had the great privilege of spending a little bit of time scientifically with Earl, and I spent a little time on the John Muir Trail as well. And if you notice, his last paper, Distribution of Muscle Spindles in a simply structured muscle, integrated total sensory representation. There's a name on there, Dan Eldred, from JPL, and I think it's probably one of the few times you'll ever see an author from JPL on a spindle paper, but there it is, and that was last paper. So it's really been a privilege to have, spend a little time on Earl's scientific journey, and also backpacking on the John Muir Trail. Thank you.